The Crew Dragon capsule is the spacecraft that houses the crew. It is replacing the Cargo Dragon capsule that was previously used on SpaceX resupply missions to the International Space Station.
The Dragon spacecraft that we'll be using to carry astronauts to the space station and bring them home is really a 21st century spaceship.
My first impression of the inside of Crew Dragon, I was amazed. It's obviously a modern space vehicle. It's a very sleek design inside, very comfortable. The seats are actually car racing seats, so the safety factors go up considerably.
We've flown Crew Dragon already to the space station and back. We subsequently made a lot of changes, improvements, but we also just have to be absolutely paranoid about safety.
Well, the experience of training in an accurate capsule with a spacesuit is invaluable.
Bob and Doug wore their spacesuits in the simulation because we want training to be as flight-like as possible for them.
SpaceX Dragon, we are ready to pressurize.
When you have all your equipment on, it allows you to get more comfortable in a situation. So the more you can train in those suits, the better you'll be on the real day.
It's exciting to see, modern components in a spacecraft.
You get very used to the shuttle, the 2,000 switches, circuit breakers, the seats. It's not the most comfortable vehicle to fly in.
For those of us who've been living with switches from the 60s for all these years, to see a modern interface is something that's pretty exciting.
SpaceX Dragon, we've got 2 good LEDs.
Copy all, Dragon.
Some of the great innovations that we've made, we have these wonderful touch screens, so you can see everything that's going on in the vehicle. You can get all the data that you need about the vehicle, and you can also control the vehicle all from these touch screens.
The gloves are compatible with the touchscreen. It's imperative because there are operations you need to do with the gloves on.
Our tablets are updated.
The Dragon capsule is almost completely automated, so it should be able to fly the entire flight without us intervening at all if everything goes normally. And I think it's the way of the future with vehicles. I mean, we see that now with cars, we see it with airplanes, and this is just the next logical step.
You should monitor your Dragon longitude for knowledge about initiation of claw separation prep.
When you think about automation, it's a layer of complexity in software that needs to be verified. So the task for crew on a good day is hopefully that they don't need to do much. On a bad day, they need to understand exactly when and how they need to respond to the vehicle's behavior and what it's doing.
Dragon SpaceX, come check.
SpaceX Dragon, we've got you loud and clear.
Every single phase of the mission will be simulated. So we have launch sims, we have approach to station, entry, descent, and landing. And every single phase has failures that are unique to that phase and require different responses.
Dragon, we are going to step into the scenario.
Ultimately, even though it's able to autonomously fly, we want to make sure that the crew understands what's happening and that they can take control at any point in time to ensure that their own safety as well.
We can manually intervene if we think things are not going the way they should be with the automation.
Dragon SpaceX for a flight computer.
Yeah, looks like we lost it.
Today, the astronauts are training for a scenario in which the flight computers fail. Since the Dragon crew capsule is totally automated, it relies on the computers for almost everything. With the computers down, this could be a dangerous situation for the astronauts.
We see one of your flight computer processes are not controlling the vehicle.
So what we'll do in training is we break Dragon.
Dragon SpaceX, please proceed to reboot flight computers.
So if the flight computer goes down, we teach them how to reboot it.
Okay, we've initiated the flight computer reboot.
And we see the same on the ground, we're following them. Thanks.
During simulations, you'll see a lot of anomalies, malfunctions. Sarah and some of our other simulation supervisors, they relish those opportunities.
The deorbit burn has been interrupted. We are investigating the root cause on the ground.
Dragon copies.
It's really good not only for Bob and I as the crew, but it's also for the team on the ground. It really throws the team different curveballs.
Flight computer has transitioned to deorbit burn.
We show all our displays back up.
And that's great news.
Splashdown.
NASA has required that SpaceX's design of the Crew Dragon capsule has a significantly higher level of safety than its predecessor, the Space Shuttle.
Every aspect of Dragon has been tested at the subsystem level, as an entire vehicle. There's so many tests, it would blow your mind.
Even with all the safety features that SpaceX has built into their systems, NASA is also requiring the inclusion of a revolutionary new safety feature called the Launch Escape System.
If there was an emergency on the pad, the capsule is able to separate from the Falcon rocket, and that's done to protect the crew.
Our launch escape system is essentially an ejection seat for the entire spacecraft. If the computers sense a problem with the rocket, the spacecraft will automatically separate itself and fly through the air with its Super Draco engines so that it can safely splash down in the ocean with its parachutes and save the crew from an in-flight anomaly. The Crew Dragon spacecraft has two types of engines on board. The first are 16 Draco thrusters. Those are small engines that make about 100 pounds of thrust. And then there are the 8 Super Draco engines for a launch escape scenario in an emergency situation, which make thousands of pounds of thrust. Crew Dragon is utilizing 3D printing to manufacture some of the components on it. A 3D printer works by laying down layers of metal powder, and as it lays down each layer, it will melt together a specific part, and then it builds up layer by layer to create whatever shape that you want. And so this is really useful when we look at things like printing an engine that needs many fluid passages in it. It needs to be a very interesting organic shape. And because you melt it together layer by layer, you can make hollow parts, you can make very interesting shapes that would be difficult to make by any other method.
In 2015, SpaceX performed a preliminary pad abort test of their launch escape system.
Our pad abort test was performed to ensure that our spacecraft design could escape the launch pad safely to the water in the event of an emergency.
3, 2, 1, launch.
During an escape, they will likely pull between 4 and 6 Gs. It depends on the different variables and the situation. I think a roller coaster is under 3 Gs.
We're over 1 kilometer. Truck deploy. Drug to the pit. Passing through 600 meters.
The pad abort test was a precursor to a much larger challenge called the in-flight abort test.
In-flight abort is a similar test, but it tests a different set of conditions. Instead of demonstrating separation from a rocket on the launch pad, the in-flight abort test will demonstrate separation from a rocket that is actively flying through the atmosphere. If there's a problem with the rocket, the in-flight abort test will show how the capsule can eject itself from the rocket and safely bring the crew down to the water.
The stakes for the in-flight abort test are massive. It is the last critical milestone that SpaceX must pass in order to be allowed to fly NASA astronauts.
Ignition, liftoff.
4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
One of my strongest memories as a child was in 5th grade. We watched the Space Shuttle Challenger blow up. The loss of the entire crew was a result of the fact that there was no launch abort system. It shuts down the program for a period of years. What we want to do now is we want to get to a day where when there is a catastrophic failure, we have a launch abort system that keeps our crew safe.